To start out our next unit, we're going to talk about maximums and minimums. And there's a couple different kinds of maxes and mins that we'll talk about. There's absolute maximum value. That is the largest y value. Keep in mind, always the y value that occurs over the domain of the function. And this absolute max can occur at the endpoints of the domain. So we're looking for the biggest possible y value, or for an absolute minimum, the smallest possible y value. And that is the absolute minimum value that occurs over the designated domain of x's. That also, being an absolute max, absolute min, means it can occur at the endpoints. Now another term, local max, local min, again, largest or smallest y values, also known as relative max, relative min. Those are the biggest y values that occur inside of an interval. So if we're given a particular domain from, let's say, -2 to 3, let's say we're given a domain from -2 to 3, including -2 to 3, the local max or the local min is the biggest y value inside the interval, not occurring at the endpoints. Okay? And those we usually find by being a top of a hill or down in the valley. Could occur at a sharp point like that. But those, and there can be multiples. If we have something that's shaped like this is the bottom of a hill. This is a local min. This is a local max. This is a local min. So over some interval, you get a bottom of a hill or a top of a hill or a bottom of a hill. Those are local or relative maxes and mins. Can be multiple over a particular interval. And critical numbers. We've used this term critical values, critical numbers before. These are x values, not y values. X values that make the derivative 0 or make the derivative not exist. And we'll see shortly how these can be really helpful when we try to find maxes and mins. So let's see how we're going to use this. Now, we have something called the extreme value theorem. And that says that if we have a continuous, and this is the most important word in this whole theorem, if we have a continuous function on some closed interval, then the function does attain both an absolute max and an absolute min at some x value, and it could be even at the endpoints in the interval. There's always an absolute max, there's always an absolute min, as long as you are continuous on the closed interval. Now what does that look like? Well, what if we have a constant function? If we have a constant function, then from A to B, starting at A, going over to B, this thing does have a biggest y value, and it has a smallest y value. It just happens to be the exact same number. So, since it's continuous, on a closed interval, there is an absolute max and an absolute min. What if we have one that just continues to increase as we go from A to B, or maybe it decreased as we went from A to B? Well, we can see that at the endpoints, There we're going to have the absolute minimum value. Here we're going to have the absolute maximum value. Closed interval, continuous. Now here we got an unusual situation. We just see the absolute minimum value is right here. The absolute maximum value is right there. But we're only getting close to those values. We're not actually getting there. This is a situation where there is no absolute max nor absolute min. But that's understandable because this isn't continuous. Extreme value theorem doesn't apply to this situation because we're not continuous. And we got this situation. Let's see, we are continuous from A to B. So we got to have an absolute max, got to have an absolute min. Looks like the absolute max happens at an endpoint. And the absolute minimum value appears to occur maybe a couple of times. Now, there is only one value. There is only one y value. But it occurs a couple of times. And so that would be the absolute minimum value, but occurs at this x value right here and this x value right here. So those are some examples of the extreme value theorem. Now, I'd like you to graph this. 3x to the fourth minus 4x to the third minus 12x squared plus 1. Giving you the window. And so press pause and go ahead and graph that thing. It should look like what we've got right here. But I'm going to want you to toggle back and forth between pause and play and see if we end up with some of the same values here. We would like local and absolute maxes and mins. So go ahead and graph that. And when you come back, we'll talk about what we want to find. All right, I would like to find local mins. Now, local min's the bottom of a hill. I have a bottom of a hill right here, which appears to be at -1, but I'm not positive. I got a bottom of a hill here. It appears to occur when x is 2, but I'm not positive. And so what I'm going to have to do is I'm going to have to do a second trace. Those are the buttons I push. And those will activate calculate. And then I'm going to have to say that I'd like to calculate a minimum. And when I want to calculate this minimum here, I've got to give it an interval. I've got to give it a left bound and a right bound. Maybe I say it's somewhere between -1.5, and I press enter for the left bound, and -0.5 for the right bound. It then asks me to guess. And I can guess -1 if I'd like. Or I can just press enter again. It'll tell me what I get. And I'd like you to do the same thing here. And I'd like you to figure out what are those points. Let's find the points of local minimum. So press pause. Go ahead and do that. Now when you found those, I think you found that at -1, we were at -4. And that at 2, we're at -31. Those were the local or relative minimums. Those occur inside the interval. Can't happen at -2, can't happen at 3. Now there is a local max. There is a top of a hill in this interval. And so I'd like you to use the same second trace, but choose the maximum option. And so press pause, and would you find that point right there? If you find that point accurately, you should find that is the point 0, 1. So those are the tops and bottoms of the hills inside this interval. Those are the local or relative maxes and mins. Now, important to realize that if they ask you for at what point is there a local min, these are the points. Or maybe they ask you at what x value does a local min occur, and you would say -1 and 2. They might ask you for local minimum values. They ask you for values, they only want the y's. So the way the question is asked is going to determine how you answer. Now, I specified verbally that I want points. Now, what about absolute max, absolute min? I'd like the point of absolute max. Well, not sure what this is. Not sure what this is. It looks like at -2 it's going to be a little bit higher. If I check out what's going on at -2, I think I'm going to get my absolute max. I could trace to find that and just say trace and then enter -2. And I find that my y value is 33. Had I checked over here at 3, I think at 3 we only had 28. So that was not the absolute max. Absolute min, what's the absolute smallest y value that we get over this entire interval? Well, that again occurs right here at 2. And if I'm asked for the point, I'm going to say 2, -31. If I'm asked for the x value, I'm only giving this. If I'm asked for the absolute minimum value, I'm giving that. So when we're able to use our graphing calculator, calculating what these values are is something we need to practice a little bit, this whole calculate feature. Now, the closed interval method for finding an absolute max or an absolute min. Anytime you are asked to find the max or min, find a max or min, if you are given a domain which is a closed interval, they're asking for absolute, even though they didn't use the term, find the absolute max or absolute min. They just said, find the max or min. But if they give you a closed interval, they're talking absolute max, absolute min. And there are 3 steps to this. 1, find all the critical values, all the places where the derivative is 0, all the places where the derivative doesn't exist. And then find the value of the function, find the y value at those critical numbers. Finally, find the value of the function at the end points of the interval. Remember, it's a closed interval. It does include those numbers. And the biggest y value that we find, well, that's the absolute max. And the smallest y value that we found among these things in steps 1, 2, and 3, actually steps 2 and 3, those are going to be the absolute max, absolute min. So let's put that into practice here. Find the absolute max, absolute min values for this function right here. Here's our interval. Well, step 1, let's find the critical values. Let's take the derivative and set it equal to 0. This exists everywhere, this derivative. So I'm not going to be concerned about where it doesn't exist. But let's find where this is equal to 0. Now I think I'd probably have to factor it, and I'll factor out of 3x. And I can see that this is going to be 0 at the critical values of x equals 0 and x equals 4. Step 1 has been completed. Step 2. Let's find the value of the function. Let's find the y value at these critical numbers. Well, at 0, if I put a 0 back into my function here, what do you get? If I put a 4 into that function, what do I get? Well, why don't you press pause, put 4 in there, see what you get and compare to what I get. Okay, I'm getting negative 27. And then the third thing we're going to do is we're going to find the value of the function at these endpoints. If I put a negative 3 into this same function right here, what do you get? If I put a 5 in there, what do you get? Why don't you press pause, you find those values, I'll find those values, we'll compare. Okay, that's what I got. Now the question says find the absolute max and absolute min values. I've got to answer the question the way it was asked. And the absolute maximum value, the biggest y value that I got, of all of these points right here, I think the absolute maximum value is equal to 5. That's the biggest y that was achieved inside the interval or at the endpoints. And the absolute minimum value, smallest y value that I got anywhere in or on this interval. Hope your numbers agree with mine. All right, let's take advantage of an opportunity to practice some of these skills on maxes and mins.